All right, so in this lesson, we're going to take a look at another example where we're applying a combination of transformations to a given graph. So I'm given a graph on the right-hand side here, and what we want to do is take the graph and sketch the graph of y is equal to f of 2x plus 4. Okay, so there's a transform function. First thing you want to do is you want to identify all the parameters involved with this function. So we're going to compare it to the general form y minus k is equal to a times f of b times x minus 4, and finally you close those brackets. So there's a general form of a function being transformed, but let's actually go through and find out what all our parameters are. But you might want to notice something a little funny about the given transform function. 2x plus 4, so that expression inside the function, does that look like the general form? Namely, that expression right there, b times x minus h. Do those two expressions match in terms of their form? Well, no, they don't. And that's going to be a huge issue, especially when you identify what your h value is. So the first thing you need to make sure is when you're given a function, the transform function, you need to make sure that you factor out the b. Factor out the b. Okay, and this is something that your teachers are going to stress. Okay, this is where the diploma really tests you on whether or not you know what you're doing. They will give you tricks just like this, and it is your job to recognize that this expression 2x plus 4 does not match the general form of function being transformed. So you need to make sure that your b value is factored out. So if I factor out my b value, what I'm end up getting is y is equal to 2 brackets x plus 4 divided by 2 gives you 2. Okay, so factor out the 2. Does that look a little better? Yeah, so this expression looks a lot more than our general form. So from here, you can go ahead and identify all your parameters. So first thing you want to do is identify your k value. As you can tell, there is no k value. So k is equal to 0, hence we have no vertical translations. Do we have any a values? We actually do have an a value. That's just 1, but that actually doesn't mean we have a vertical stretch here, okay? Do we have a b value? Yes, we do. That's right there. So positive 2, okay? And what does that mean? Well, that means we have a horizontal stretch, but what is the factor? Well, it was really funny with the b value because if you wanted to find the stretch factor, you had to take the reciprocal of your b value. So all my x coordinates are actually being halved in this transformation. And then finally, you want to identify your h value. We have an x plus 4, so once again, you have to take the opposite sign. So our h value is going to be negative 2, okay? All right, so what's going on here with that negative 2? Well, that means we have a horizontal translation, and we're actually going 2 units to the left. Okay? All right, so there are all my transformations. What's actually happening here is 2. We have a horizontal stretch factor by a factor 1/2, and we have a horizontal translation 2 units left. All right, so enough of that. Let's actually go ahead and perform our transformations here. So we have a point x, y on the original graph. When we apply our transformations, what's going to happen is that you're going to take your x coordinates and divide by whatever your b value is. Remember, our b value was 2. Okay, so x divided by 2, and then we're going to add our h value, but remember, our h value is negative 2, so minus 2. And remember, we had no transformations happening with our y values. So our y values are actually going to stay the same under this type of transformation function. Okay, so let's go ahead and pick a few points from the original graph. I have negative 8, 0 as 1. I'm going to pick one at negative 3, 5. Okay, and let's pick this point right here for negative 2. And finally, the second x-intercept is 6, 0. So let's go ahead and apply all of our transformations here. So we're taking all our x coordinates are going to change, and all the y coordinates are going to stay the same. So if negative 8 divided by 2 minus 2 gives you the first point, and this is comma 0. We have negative 3 divided by 2 is going to give you, oh, sorry, not negative 3 over 2, and then finally subtract 2, sorry about that, and positive 5. Okay, let's keep going. We have 4 divided by 2 minus 2, comma, negative 2. And finally, we have 6 divided by 2 minus 2, and the y value stays the same at 0. All right, so here are my points. Obviously, they don't look very nice. Let's go ahead and carry out our operation. So negative, let's start with the first coordinate. Negative 2 over positive 2 gives you negative 4 minus a 2 is giving you a negative 6. Okay, so I have to be really careful here with my erasing here. Let's make this smaller. Okay. We have negative 3 halves minus a 2, which is going to give me negative 3.5. Okay, so I'm going to change it to a decimal because it's a lot easier to deal with when you're plotting. 4 divided by 2 gives me 2, minus 2 gives me 0. All right, and finally 6 divided by 2 gives you 3, minus 2 gives you 1. All right, so here are my points. Last step obviously is to graph them and join them. So negative 6 comma 0 is right there. Negative 3.5. I'm just going to be really careful here. So 3.5, 5 right there. Okay. And 0, negative 2 right there. And finally 1 comma 0. So 1 comma 0 is going to be right there. So if I sketch this graph, it's going to look just like this. I'm going to try my best to make it as nice looking as possible. Okay, so notice all your x coordinates were halved, and they also moved over 2 units to the left there. So that's it. That's how you apply a combination of transformations to a graph. And this lesson was specifically made to make sure that you guys made sure you remember to always factor out your b. Okay, so factor out your b values. Don't make that mistake on your diploma or it's going to drive you nutters. And so that's it for my lesson.